Okay, this video is going to start our discussion on operations on polynomials. All right, we're going to really be able to do three things when we're finished, all right, which is add or subtract polynomials and then multiply polynomials. And then we'll look at some problems where you may have to incorporate both of those skills, all right, in a given particular problem. So before we get to the actual adding and solving polynomials, we need to discuss, all right, a couple of things. So this is all terminology, so that we are all saying the same things and understand the words that come up in our conversations about polynomials. The first is the degree of a polynomial. And the degree of a polynomial is found by finding the highest exponent in the polynomial. So if we look at 3x plus 1, we would say this is a first degree polynomial. In this case, it's also a linear function. All right. If we look at 7x squared minus 8x plus 9, okay, we would say that this would be a second degree polynomial, all right, because the highest exponent in this problem is a 2. Now, not every time is the first term the highest power in the polynomial. So if we look at the next example, we have 9x to the 5th minus 14x squared plus 14x to the 8th power minus 9x. So even though this is not the leading term, okay, this would be an 8th degree, all right, polynomial. So when you look at, that D is not very good, so let's do that. There we go. So 8th degree polynomial. So when you look at a polynomial and try to determine the degree of the polynomial, all right, you always want to look for the highest power of x, or the variable in the problem. Now, to help us a little bit, all right, with that, we usually agree that we're going to do something called with writing our polynomials, all right, to write it in either ascending order or descending order. Now, ascending order would mean that we would go from the lowest exponent to the highest exponent. You typically don't see that very often, although it's not incorrect. Typically, the more common form is to see in a polynomial written in what we call descending order, which means we start with the highest degree and we write that down to the lowest degree of the variable within our polynomial. So if we look at that last example, all right, of 9x to the 5th minus 14x squared plus 14x to the 8th minus 9x, if we wanted to write that in descending order, we would place the highest term first, including the coefficient of the x to the 8th, so 4x to the 8th, plus 9x to the 5th, minus 14x squared, minus 9x. So we typically do that because it makes things much easier. It's also going to make some of our problems much easier when we add and subtract and multiply and those kind of things, all right, in just a little bit. So now, if we look at the leading term, okay, so the leading term is typically, once we write it in descending order, is that highest degree term. Okay, we talk about that 4 is the leading coefficient. All right, so once we have this leading term in place, all right, we say this is the leading coefficient. All right, so that is really, all right, some of the initial terminology vocabulary that we need to make sure we're all good on. So now, so what I'd like you to do, all right, is just go ahead and pause the video real quick, all right, and just go ahead and write this in descending order, and then identify the leading coefficient and the degree of the polynomial. Okay, let's see how you did. All right, so I'm going to write the highest degree term first, so 2x to the 12th. Then my next highest degree would be the x to the 7th term, and then the x to the 5th term, and then let's see, so we have our 12th term, our 7th term, our 5th term, and so that leaves two other terms, all right, our first degree term and then our constant term plus 9. So this would be in descending order. All right, so then 2 would be the leading coefficient, and then this would be a 12th degree, all right, polynomial. All right. So hopefully you understand that. If not, please note any questions you have and bring those to class. All right, so a couple other pieces of information. All right, so sometimes we describe polynomials by the number of terms it possesses. So when we look at this linear function right here, 3x plus 1, we would call this a binomial because it has two terms. All right, if we look at the next one, 7x squared minus 8x plus 9, that would be a trinomial, all right, or three terms. And then 7x would just be a monomial. Now, when we have binomials and trinomials, all right, they do not necessarily have to be in descending order once again, all right. They don't necessarily have to go 2, 1, 0. All right, so you can have different mixes of powers in different orders, but as long as there's 2 terms, it's a binomial. If there's 3 terms, it's a trinomial, and if there's 1 term, there's a monomial. We don't really refer to anything above 3 terms with a special name, but these are the 3 of the most common, so those are the terms that we use the most. All right, so now that we have a bit of that common language out of the way, let's actually talk about adding and subtracting polynomials. So what we are really doing when we add and subtract polynomials, we're really just combining like terms. All right, so we're just going to take problems and we're going to rewrite them and line up all of the like terms. Now let's make sure we understand what a like term is. Okay, a like term, all right, would be anything that has the same base to the same power. So for example, in this problem, all right, I have 5x squared and then minus 9x plus 8. And I want to add that to this polynomial. So I can only add like terms, which means things with the same base and the same power. So if I look at this first term, okay, this is a base x to a power of 2. So it can only be combined with base x to power 2. So what I'm going to do is just write this right underneath this here, and I'm going to eventually come back and add those. All right, and then I look here, my second term here, this is base x power of 1, so it can only be combined with something else with base x power of 1. So I'm going to write that right below this term. And then I have a constant term, which means it can only be added to another constant term. So then I'm going to put the plus 19 right here. And now what I'm going to do is kind of just use this to organize my work each time, so I know all my like terms are going to be in the same columns here. So 5x squared plus, and then we're always going to be adding here, plus negative 7x squared would be negative 2x squared. Negative 9x plus negative 5x would be negative 14x. And then 8 plus 19 would be positive 27. So I'm going to do this format every time to help organize and gather all of my like terms. Okay, let's look at another example here. All right, so notice now we are subtracting. All right, so now what I'm going to do as I organize is I'm going to distribute the subtraction to each of our terms. So notice it's very similar to our prior problem. So if I just go ahead and rewrite our terms here, all right, so I'm going to say 5x squared minus 9x plus 8. Now, why I said we were always adding is because when we have a negative, we want to just go ahead and distribute that negative to each of the terms as we realign them with their like terms in our columns over here. And then it really is always an addition problem. So when I subtract a negative 7x squared, that's really a positive x squared, so or positive 7x squared, so I'm going to put that right here. And when I subtract negative 5x, that's really like adding 5x. And when I subtract 19, that's just like subtracting 19. And so once again, all right, I'm making sure all my like terms are in the same column. So as I look vertically, I shouldn't see anything with a different power. And if I do, then I know I can't combine those, so I should reorganize my work. So 5 plus 7x squared would be 12x squared. Negative 9x's plus 5x's would be negative 4x's. And then 18 minus 9 would be negative 11. So I now have, all right, subtracted those two polynomials. All right, so let's take a look at another example here, all right, like this, okay? So once again, what I want to do is organize my work to best help me combine my like terms. So now what you will notice is that if you look at this, I'm missing some terms here. So I'm going to put, all right, some spaces in here to account for the missing powers. So as I rewrite this, I'm going to have negative 7x to the 4th. Notice I'm missing an x to the 3rd power, so I'm going to leave a little space here, and then I'm going to put, all right, a negative 9x squared. I'm missing an x term, and so then I'm just going to skip a little space and put a plus 8. And the reason I'm doing that is because when I realign my other terms from my other polynomials, they may fit into these slots, and I don't want the same different powers over each other. Okay, so now I need to subtract our trinomial here. Now once again, I'm going to distribute this negative to each term as I reorganize my work. So when I subtract 8x cubed, that's really negative 8x cubed. So notice this is the x cubed column. All right, so I'm going to put that negative 8x cubed here. Now if it helps you, you might want to put a placeholder in and put like 0x cubed if you're missing a term, and you could put plus 0x. So then you have everything in descending order, you have every power accounted for, and then once again maybe that helps you align everything correctly. Okay, now if I subtract my second term here, I would be subtracting negative 11 squared, all right, and then I would subtract 1, and that has to go with my constant, so minus 1 here. All right. So now I have negative 7x to the 4th. Okay, and then I have these two, I combine those. I have these two, so I combine those. There's no x's, so I don't. You could write 0x if you want. You do not have to. All right, and then 8 minus 1 would be a positive 7. So then, and like I said, we're always adding right here. And then that would be our answer. All right, so what I'm going to do now is give you some time, all right, and give you some example problems to work. Oh, actually, I got one more example here, so let's do this one. All right, and then I'll send you off to work on your own. All right, so once again, let's look at this guy. All right, so as I write this out once again, all right, I'm going to, count for all my powers. So there's my fourth power term, my third power term. Now notice I do not have an x squared, so I'm going to put 0x squared as a placeholder, minus 13x plus 14. And now, since I'm adding, I can just take these terms and align them where they go. So I have an x cubed term, or an x to the third term, so I'm going to align that right here. I have a minus 4x, so I'm going to align that right here. I have a positive 5, so I'm going to align that right here. All right, and now I just go ahead and add everything up. So I only have the 8x to the 4th. 6 minus 9, or 6 plus negative 9, is negative 3x cubed. I don't have any x terms. And then I have minus 17x, and then plus 19. All right, so there you go. And like I said, if you had decided to write it like this, and you put the plus 0x squared into that, that is technically correct. Okay, but if this were a multiple choice question on a standardized test, you would never see the 0x squared. You would see it written like so. All right, so now here's some example problems for you. All right, now because I haven't done one of these yet, I'm going to go ahead and do the first one with you just to show you that, okay, if we were adding multiple terms or multiple polynomials, it's not really any different than what we've done. Okay, so if I look at this, I'm going to go ahead and rewrite this guy. So negative 7x to the 4th. I'm going to put my placeholder in, and then 6x squared minus 3x, and then plus 8. Now I just go to this guy. Okay, so I have an x squared term. All right, so I'm going to put that right below the other x squared term. I'm going to put a plus here to remind me that's positive. I have a linear term, or an x to the first power term, so I'm going to put that there. And then I just go to the next polynomial and I continue with the pattern. Oh, I've got an x cubed term. Now I do take and start a new line, all right, for each polynomial. Then 8x squared, because you can see that once again you may end up with, all right, 3 terms here, all right, and then a plus 4x, and then I have a minus 6. And then once again, all we have to do is just add down. Okay, so we're adding all these. So negative 7x to the 4th plus 9x cubed plus 20x squared minus 3x, and then plus 2. All right, so now go ahead and pause the video and try examples 2 and 3. Okay, once you finish, go ahead and turn the video back on, and we'll see how you did. All right, so let's check your work. Okay, so you can see there's the answer to the first one. Okay, so on the next one here, negative x to the 5th plus 4x cubed minus 4x plus 4. And then on example 3, negative 8x to the 5th minus 3x cubed plus 3x squared minus x plus 5. All right, so once again, all right, let's go ahead and move to some more example problems for you. All right, so now notice that you have, all right, examples 4, 5, and 6, and now you're subtracting the second and the third polynomials here. So don't forget to distribute that negative to each term in your parentheses here as you reorganize your work. So once again, go ahead and pause the video, all right, and try those 3 problems. Okay, let's see how you did. All right, and there are the answers to these problems. All right, so that wraps up our lesson on adding and subtracting polynomials. So if you have any questions, please note those and bring those to class with you. That way we can discuss those, and then we'll jump right into the homework for this lesson.